Welcome to World of Fusion. This is part 8 of PCC series. Piston, connecting rod and crankshaft. If you missed previous video, please do watch through the link in description. Without further ado, let's get started. Make sure you open our assembly file. Up to this, we already did. Now we need to create a component. Right-click and create a component. Rename it as Piston. Saying OK to create the component. It is activated. I just don't want to see these components, that is crankshaft and connecting rod. I'm going to hide them. Fine, now let's get started with piston. Now our piston is activated and I'm going to create a sketch. Front plane, that is XZ plane. Draw this profile. While drawing, make sure it is close to 70 millimeters. Because if you draw bigger length line, you may have scaling issue. When you give constraints and dimensions, just make sure it is close to 70 millimeters. Fine. Now I'm going to draw the profile for the piston rings and this line. Also, make sure it is close to 40 millimeters. And come down. Draw this profile. Make sure you get these constraints or else you apply perpendicular constraint. These lines are perpendicular to each other. And also you just trace back so that it is vertical. We need 3 like this for seating the piston rings. You know, right? Piston rings will help in sealing the bore. Trace this and close the profile. Now we have our closed profile. Fine, let's give the dimensions. But before that, make sure you give all the constraints. Then you proceed for the dimensions. So, here I'm just pressing escape to get rid of the line command. And I want to make sure that all these points are vertical. So I'm going to control select all these points and selecting horizontal vertical constraint. So, now they are all vertical. If I move this, all the points will move. Similarly for this one also. Just select the points and apply the horizontal constraint now. Perfect. And apply the equal constraints for these 2 lines. Select the lines and apply the equal constraints. Very easy. Pressing escape to get rid of the constraint. And yeah, I think that's it. So, just give the dimensions now. Sketch dimension. Let the length of this line be 72 millimeters. And this is 42.5. So all these dimensions will be shared with you. So you can check the document and provide the dimensions carefully. Apply equal constraint over here also. Yes. These lines are also equal, right? Apply the equal constraint. Okay, so if we give one dimension for this, it is enough, so 3.5. Yes, so this basic profile we completed. Now let's draw the inner profile, so that we will get our profile for the revolve. We can use axis to make it 360 degrees. So, just observe. This is very important. And a simple line from this point just like this. And hold your left mouse button to get the curve and simply bring the curve like this. One more curve just like this. and again one more curve just like this. And all will be applied with the tangents. If not, you just apply it manually. Okay, so here the tangent constraint is not applied like this. See, these two curves are tangent, so let's inspect from the top. So, here we go to the tangent and one more and again tangent. But here we did not got the tangent. So you can select the tangent constraint and select the curve on the line. Now the tangent constraint is applied between the two. Curve is fine. Let's apply the dimensions now. This length is 20 millimeters. And the radius of this curve be 15. So, if I do that, so it is getting a little wobble, right? Try to adjust it. Or else undo and provide the smaller dimension first. This is 2 millimeters and I want these two curves to be equal. So, I select equal constraint and select the two curves. Now they both are equal. And set this line length 38 millimeters. D on the keyboard for dimension. 38 millimeters. And distance from this point to this point be 3 millimeters. And from this point to this point be 10 millimeters. Perfect. And change this radius to 15. Yes, perfect. You can take a screenshot of this to give the dimension. Just be careful that you get this same profile. I know it's a little effort, but if you miss anything, please watch it again. I'm going to finish the sketch. Home view. Revolve, select the profile and the axis be Z. Or you can select this line. Home view again, to check the preview, make sure the angle is 360 degrees and say OK. Perfect, we got our basic profile for the piston. Now we need to provide the rib over here. We will be having crown pin or piston pin, right? For that we need to create the profile and extrude cut over here. Let's create that profile. Sketch. I'm going to select the YZ plane. If you are unable to select, hold left mouse button and see the options. Pick the current option, that is YZ. Now, you can slice this. Slice it so you can see it inside. Okay, so this is the option slice. Simply draw a profile like this. Just circle first. And one more circle. And I want a line from here to here. I want this line to be horizontal about its center. And one more thing is I just press escape to get rid of that. Horizontal command, and I want this point and this point to be vertical. Fine line again from here to here. Repeat the line. Fine, so now I just want this line to be construction. So, pressing escape to get rid of all the commands, select the line, apply the construction. Awesome! So, now I want these 2 points to be symmetrical. I would like to draw one more line, that is construction line. Okay, we got this construction because while drawing, the construction command is activated. So, if you disable it, you will get a normal line. If you enable it, you will get a construction line. Okay, so make sure to select this based on the purpose. This is all for part 8. If you have any queries, I'll be more than happy to answer them via comments. In the part 9 we will finish this piston model. Now that you have watched till the last, consider liking, subscribing and do follow our Instagram. We post daily quiz and updates on fusion and tutorials. Thank you so much. See you in part 9.